Hey guys, Pankaj here. Welcome back to my YouTube channel. So yesterday we saw NLP part 1. Okay, so there we saw what is NLP, what is the application, and what is the future of NLP, and what are the fundamental steps involved behind running NLP for text processing, right? And we were there up to like very basic regular expression we saw, and we did very small cleaning part, right? So today we'll see a little more. So let me share my desktop. Okay, so yesterday we installed the NLTK library. We saw a lot of functions and how to download corpora or corpus. Okay, and we took some sample text from wiki page about Albert Einstein, and we were doing some processing on that, right? So this was our text. So let me just run once again this library and just load it. Okay, so in NLP, we are loading NLTK as NLP, NLTK.tokenize. So we'll be seeing what is tokenization. Okay, so we are going to do tokenization using conventional method as well as some function whatever is available in NLTK. So we'll see word tokenization and sentence tokenization and what are various stop words available in NLTK, which is by default available. Okay, and later we'll see what is stemming, what is lemmatization, and do stemming using porter stemmer, snowball stemmer, and regex stemmer. So we'll see a lot of examples. Then you can easily understand what are stemmer and how it works. So we have seen NLTK version that is 3.6.2, and we loaded the sample text. So let me load again. And we printed the text. Okay, so up to here all good. Now text cleaning, removing unwanted character. Okay, so what I mean to say here, unwanted character basically, so when you loaded the text from wiki page, see what is happening here. So we made it lowercase because to maintain the uniformity. Okay, and unwanted character in this is, let me just scroll. Yeah, so we see this bracket, then slash, then apostrophe, or maybe single quote, double quote, and lot of semicolon and square bracket with some numbers, and there are some Unicode numbers also, right? So like this, we have a lot of special character or unwanted character. So how to remove them? Basically, what you need is basically just a number and alphabet from A to Z. Okay, so anything other than that, let's remove it. So this is what we wrote, one small regular expression, right? So this first character, if you're using caret within the square bracket in regular expression, means anything other than these character set. Whatever is available, let's remove it. So we have used substitute operation of regular expression. So anything other than this, whatever we see, substitute them with space in the text string. Okay, so this is what we executed. Let's run it. Okay, so before removing them, this is what we are getting, and after removing, we are getting this. So if you see here, right, all the special character or the bracket, everything is gone. We have all only YA is gone. So let me just see. Okay, print text, new text. Okay, YA is missing. We have the lower test case or not. Let me just see. I think we did not take the text. We haven't executed lower. Okay, so A will be there. Yeah, now it should come. Because we took the directly main string, right, where capital A is there. That's why this got removed. From this, we should have small a also. Yeah, now it is fine. Okay, so Albert Einstein, after that, you see this special character is gone. Then we have A, and this is also kind of special Unicode character. Okay, this is written in different language. That's why this has been removed. And other things are normal English character. That's why we see that. Okay, and after that, we got this square bracket along with the number that is also has been removed. Okay, so not only these steps involved, we have to run this particular step multiple times so that other kind of character or maybe single letter character also, if you're not interested, you're going to remove, or maybe you are not interested with number, that also you're going to remove. Okay, so maybe what I'll do, I'll just take little more number of character up to 200 and see. Okay, so all looks fine. What we'll do, we are going to remove all the character which is just of single length. Okay, like we don't want like normal T, single character T, single character A, and like that. This is adding unnecessary, because in the NLP, right, this will be treated as a single letter word. Okay, but is it going to add some value? Of course no, right? So we are going to remove them. So how to remove? Now I am going to take same regular expression, and this time my text will be new text because I'm going to remove from there. And let's modify this particular text. Why it is not taking? Yeah. Okay. So now our pattern will be different. So for now, we are going to remove any single character which is just present. Okay. So this is what I'm talking. This particular N, and we have this 6. Anyway, we can remove the number also, single character, and we have T. This one, anything is fine. So first we have to remove all the word character. Okay, or maybe to make it more specific, anything between A to Z of length single, right? So if you don't mention plus, then it is fine. If you mention plus, then sorry, if you don't mention plus, then it's fine because it is just exactly looking at single letter. Okay, but is this a word? No, right? So what we can do, we can take word character and let's define a boundary. So /b and /b means any single character, before that some space is there and after that some space is there. Okay, so that's where we denote this as a boundary character class. So instead of using double slash, I'll use raw data, and let's remove it and see what is happening. So I'll run this here. So I leave this for your reference. Okay, now let's run this one and see what is happening. So now in this particular class, in this particular string, you see Albert Einstein, this A is gone because it is not required. This is also kind of treated as a stop word. We'll see later after this. And we have like N, then we have what else? This A and all are gone. Okay, so now since it is gone, it is adding unnecessary spaces. So now let's work on this and remove multiple spaces to single space. Okay, so I'll just copy and paste it here. I'm going to write same pattern with different regular expression pattern. Okay, so what I'll do here, if I see any white space, that is slash, it could be /tab, /r, /s, / and anything, right? So I'm talking about exactly white space, that is /s. If I have exactly more than one, right, make this as a single space. Okay, so exactly one, anyway, it will be one space. If it is more than one also, it is going to treat as multiple white spaces and make it to single space. So you see here, now you will notice the difference. This multiple space, all will be converted to single. Now you see a very clear difference. Okay, here and here. Okay, so that's about this. Now, in case you would like to remove the number also, let's say I'm not interested in numbers, right? So what I can do after removing space, I can remove numbers as well. So let's say any digit. I don't want to remove at least years, that is like 1900 to 2000 or 2022, right? I don't want to remove, but rather I would like to remove those numbers which is just 2 digits, which might not be adding much value because this could be just a date. Okay, so right now it doesn't make any sense. So I'll just take /d. Wherever it is there, just make it a space. So you see here earlier it was 14, now 14 is not there. 1879 is also gone. Okay, so now we have to put a boundary. Okay, so we'll use /b. So before 2 digit, we want one space, and after 2 digit, we want another space, so that 4-digit number can be retained. Right now, this is also removed, which is not good, right? So let's run it. Yeah. So now 4-digit number remains same, but all 2-digit numbers are gone. Okay. So maybe you could have done this before removing the white space, so that we can save one more line. Otherwise, you may have to run it again because extra spaces are also getting added, right? Let's run it. Invalid syntax. Why? What is missing? Oh, this bracket is gone. Okay, so this looks much better, but still there are a couple of character which is left from those special meanings, that is like different language like ALB, TA. Those things we are going to remove in the form of, maybe you can do extra processing or you can use stop words and just get it removed. Okay, or maybe all 2-letter word also you can remove, which is not making any sense. Okay guys, so this is like much about the data cleaning, and believe me, whatever raw data or raw text data you are going to get, this is exactly you are going to do as a first step. You get the data, read it, and start doing the processing or data cleaning. Okay, and regular expression will be very heavily used here. Okay, so now we have very much clean data. Now what we are going to do, we are going to remove the stop words. Okay, so before removing stop word, what I would like to show is let's do the word counting frequency. Okay, so we have frequency distribution of each word. I think I should do it first. Okay, so why I'm going to show this first, because let's say you did the cleaning and you are going to get the frequency distribution of each word. So what will happen, you still have a lot of stop words. So stop words are like I am Pankaj. Okay, so am is nothing but a stop word here. Okay, he is going to market, is also a stop market, to is also a stop word. Okay, so those are still there or sitting in the raw data whatever you have cleaned. Okay, so whenever you are going to count the frequency of each word, you will see or you will notice that those kind of stop words are dominating, much more dominating other words. Okay, so count of those stop word will be heavily used in, like if your paragraph is very big, definitely their count will be much more bigger than any special word which have been used. Okay, so unnecessary it is dominating other word, which doesn't make any sense. So we will do those kind of cleaning, and it will automatically, so the focus, or it will automatically start focusing on those word which is very rarely used and which makes sense in your data. Okay, so let's get the frequency now. Okay, before that, yeah, let me show what tokenizer first. To do the frequency counting, we need to do first word tokenization. Okay, so what is word tokenizer? Let's talk about this first, then we'll come back to frequency distribution. So as I mentioned in the yesterday video, right, when you have the sentence that is filled with a lot of words, right? So you need to divide or filter those words separately. And that is called morphological or lexical analysis, right? So breaking the sentence into the word or breaking the paragraph into the sentences, that is sentence tokenizer. So first we'll see word tokenizer. So let's say I'm giving one example, A equal to, my name is Pankaj from PyCSR. Okay, so this is your statement, normal statement. Okay, in case I want to do word tokenization for this particular sentence, what I have to do? The very simple process is, which we have already seen the string, right? A dot split with space. So what it will do? It is going to cut down the spaces and just make all the word as a list of all the word. This is your word tokenization. Okay, and that is what we are going to do for this particular sentence, whatever is clean. Okay, so let's get the word tokenization now. So we have two ways to do that. Either you do split method and split with the space, or we have direct function called word tokenization. So if you see here in NLTK, we directly have word tokenize. Okay, so let's go there. Where is my, this one? Yeah. So I'll just say W equal to word tokenize, and what text we have? New text, right? New text or new text, print W. So now it has taken this clean data, whatever we got as after. Okay, and you see all the list. So let me just print in a better way. Okay, this looks data very clean, and you can easily find out, right? A lot of words are there. It includes a lot of stop words like off, then we have on, then in, and you'll see it is dominating because once we see the count, right? So we'll see all these kind of stop words are dominating. They are more occurrence in the text other than the rare occurred data or rare occurred words. Okay, so this is one way of doing word tokenization. And yeah, space separate also we saw. So now let's do the frequency count. So now next job is the moment you got word tokenization or list of all the words, right? Let's do the frequency plot. So get the frequency or occurrences of each word in the given data. So we have something called frequency dist in NLP. P dot. So let's see what it needs. Why PC is running very slow? Frequency dist, okay. This is not popping out. I'll just use without space. So frequency this, then what we have list of all the words, right? So did I give word? I think I already gave. Is it capital D? Yeah, it is capital D. Okay. So frequency dist is nothing but NLP method which talks about frequency distribution of each word. Okay. So all you need to do is just pass the list of all the words. If you see here, it just needs a sample. Sample is nothing but whatever your text data. So I've given all the words and it is just going to count. Okay, so maybe what I'll do instead of w, I'll just pass new underscore text. Okay, so w makes sense. Instead of given sentence, you need to pass list of all the words. Okay, then only it is going to count. So I'll show you how exactly it is working. So we have direct function available in NLP, or what you can do, you can use a list comprehension also. Oh, sorry, dictionary comprehension. So let's do that. So for w in, maybe not w, I'll just say data or d in w, give the count. Okay, so d will be your key and their count will be w dot count the d word. Okay, this is what it is doing internally. So if you just run it, see Albert is 1 time, Einstein is 8 time. Okay, so it has printed almost all the data. Okay, so word frequency, I'll just give a name equal to this and print wf. See here, and this is what frequency distribution function has written. Okay, so whichever way you want, you can use it. For me, this is more simpler than this frequency distribution because sometimes I forget the function name, right? Both are returning the same. Okay, so now you got this particular detail. After that, we are going to plot each word. So let's see how it makes sense to visualize all the data. So I'm going to use, I think, matplotlib I have already installed. Let me just check. Yeah, it is already there. Now let's plot it. So plt dot, I'll use bar plot and my x will be nothing but all the word. Okay, list of all the words. So here we have what we got here, wf, right? Word frequency. From word frequency, I want x equal to word frequency dot all the keys, basically the name of word. And here it needs height data. Height is nothing but, sorry, not plot, this should be bar. We need height. Height is nothing but the exact count of that particular bar, right? In that bar, what is your total length or total value of that particular value? So we have already seen the bar graph, right, in matplotlib. So height equal to x dot, sorry, wf dot values. So list of all the values. Now let's plot them. It's a very huge data, right? So let's see how it looks. The data is too much, right? So it may look very clumsy. So we'll just take the sample of those data and just populate it, okay, to make it more simple. And let it come first. I think it is really too much. Okay, now it has come, right? So you see a lot of data has been plotted, then the x-axis is also plotted, right? So let's do some beautification so that it will look good. PLT dot figure fixed size equal to 16 by 4 or maybe 16 by 5 I'll give. And here, instead of taking those data, so I'm going to chop up those data. Okay, so if you see here, right, in the graph, maybe first 50% of data looks good. Okay, after that it is like most of them are like between 0 to 1 only, right? So 50% data. So what I will do, I'll just take, I don't know what is the total length, I have not yet counted. So I'll just convert this into list and just take maybe first 100 data. Okay, and here also I'll convert into list and take first 100 data. Okay, and plt dot show, maybe I'll do plt dot xticks, because everything is in xticks, everything is printed horizontal, right? So I'll make it vertical so that all the text can be seen. Xticks, we have something called rotation, give 90 degree. Okay, so let's plot this. I hope it will be quick. Okay, much better. Yeah, this looks much better. We can still truncate the data. Maybe first 80 data we can take. And if you see here, right, so my main point of showing this data is, if you see, right, the more number of time what word is occurring is nothing but your off or the, both are nothing but a stop word. Okay, so if you see this kind of plotting, right, it makes sense to remove stop words from your data before going ahead with any machine learning algorithm. Okay, because these kind of data will be, this kind of word will be dominating your other data, which is more useful, but it is not coming into picture. Okay, their count is very less. If you talk about, let's say Albert is coming one time, Einstein is coming one time, and let's say German is also used, but it is exactly coming around 4 or 5 times. But this is being dominated by off and the word. Okay, so whenever you are doing this kind of analysis, make sure that you have the count, plot them and visualize it, whether do you have stop word which is dominating other words. Okay, so this was the main idea of frequency plot. Now what we'll do, we'll remove the stop word now and again plot the frequency. Okay, so first we have to understand what is the stop words. So we have stop words here. Let me see what is the function is used. Yeah, stop words. Okay, so removing stop word, we need to see the stop word first. And stop word, it needs one parameter called what language you want, right? So if you just run it, it is not going to give anything. So we have stop word dot stop dot words. Okay, under stop word, we need all the words and what language you want. Okay, so let me interrupt it. Yeah, so this needs English. Okay. Why it is not coming? Okay, now it is coming. It is running very slowly. I don't know. I think it is loading the whole dictionary. Okay, so let me just print SW is nothing but a stop word. Print a stop word. Okay. So good thing about this NLTK, right? They have stop words available for all the languages. Okay, we are going to work only with English language. That's why we used English. Okay, in case you would like to see, let's say for example, you want to see what is my stop word for Spanish language. In case someone is going to work for Spanish language, they can use Spanish. Okay. Similarly, they want to use French, then you can use French. In case you want, let's say German, you have German language also. Okay. So these are going to be very helpful. Okay, guys. So I'll just comment it. We are going to work only on English. So this is our part which we are going to use. Okay. So now you have list of all the stop word. How you are going to remove it? So we have the word that is nothing but this, all the words, right? So how we are going to remove? We are going to iterate over each word from the word list and we will see whether that word is present in the stop word or not. If it is not present, we are good. If it is present, let's not count it. Okay. So how to convert that? Final word equal to, I am just going to use for, let's say word in W, if word in, or maybe not in stop word. Okay, then use word, else drop it. So what is my final word? Let's print it. Print final word. Okay, so if you compare the list, let me just print the length of this list also. Length of print before stop word removal. What is the length? Length of word, and after removing stop word, length of final word, which is derived from word, right? So this was 502 and after that 476. Okay, I think not very significant change, but we have good amount of change. Okay, so if you see here, the is still used. I don't know why it is removing or not. So final word. Okay, and I've used the English word, right? Let me just run again. English. So not in software, then take it, otherwise drop it. Yeah, so this is good. So it has removed good amount of words. Okay, I don't know why is has been taken. Let me see it is there or not. It is there. Why this is not removed? A lot of things are not removed. We need to find out why it is not removed. Okay, but you are getting the idea, right? So we need to work on that, and whatever words are there in stop word, don't take it. Whatever is not there, just take it into account. Okay, now let's plot this particular graph once again. So what we'll do, we'll take this particular graph and print it here as well. Maybe I'll just hide this part, otherwise your screen is filling up with all the details, right? So before and after. Okay, here it is showing 297. I think I was printing the wrong word. Now it is fine. Yeah, it is not there. Looks good. Okay, so now let's go ahead and just plot the data. Okay, so we want from final word. So list of final word keys. Oh, we need to do dictionary comprehension also, right? So that we can get the frequency count. Now get the frequency count. Frequency count equal to, again I'll take for W in final word, W colon final word dot count W. Okay, now frequency count print. Okay, yeah, now this is good, and I'm just going to use this particular frequency count here. So for frequency count all the keys, that should be good enough. And let's take only 100 values and print them. Now you'll see good amount of changes. You compare this particular graph. Maybe I'll just put it same graph again, called before and after. Okay, so this is after effect, before, and after this one. Let it print both, and we'll see the difference. So let it print. Meanwhile, we'll see this after effect. What is there? You see here, theory and relativity, all those kind of words are now coming into picture. It is now highlighted. They are having the more count, correct? So earlier it was like the, on, off, all those things were coming in, which was not making any sense. And it was hidden basically due to these count were very high, and because of high number, it was hiding the other more powerful name. Okay. So that's how whenever you do stop word filtering, that it makes more sense to get the clean data. Okay, so yeah guys, that's all for today. I think I'll be running sentence and sentence tokenizer tomorrow, and we'll see what is lemmatization and what is that stemmer. Okay, in the next video, stemming and lemmatization, and couple of more concepts, then I think we can wind up the NLP. Okay guys, so that's all for today. I hope you are liking this video, because this is one of my favorite topic, because here we are just have to deal with text data. No matter what kind of structure and unstructured, all you need to know is like string methods, like full concept with a string and regular expression techniques. That should be good enough for data cleaning. Even if you don't know about the NLTK and spatial library, we are good, because we can do all the functionality just by using string methods as well as regular expression methods. Okay guys, so please refresh those knowledge and come back to this NLTK video and just try them. Thank you guys, have a nice day. Bye bye.